This is Bala Krishnamurthy. He's one of our senior TMEs here at Aruba. And we're going to start walking you through a series of demonstrations, starting off with multicast video. Take it away.
Thank you.
All right.
Thanks, Paul. Good morning, everyone. Good morning. I'm Bala Krishnamurthy. Just to make my long name shorter, it's Bala. I've been with Aruba for the last 3 years. I'm a TME and primarily focusing on RF performance testing, competitive analysis, and a few other topics that just falls on my plate. So today, I'm going to start off with video, right? Video is definitely becoming mainstream today. Most of the EDU, especially in the EDUs and the K-12 schools, a lot of applications that are becoming multicast-oriented. Enterprises, the town hall meetings, they want it to be broadcasted to all their employees across the globe. So it is definitely kicking in big time. But as we know, there are some basic fundamental challenges in delivering multicast, which starts with it goes out at low rates. It's going to take up all your airtime, affect the performance for all your other clients, and a reliability aspect of it and whatnot. So how do we solve it? The industry has pretty much moved towards this standard way of delivering multicast, which is multicast to unicast conversion. There are a few different things that Aruba does uniquely today in terms of delivering multicast. So what we believe is it's not just in the application. It's about controlling the air and making sure all these devices are able to interact with the AP, get their own share of airtime, and once they get that share of airtime, they deliver those frames, multicast frames or unicast frames. Today, we do multicast to unicast conversion in two different ways. Right? There's something called DMO, Dynamic Multicast Optimization, that we call where the conversion happens at the controller. There is something called as a DDMO, which is Distributed Dynamic Multicast Optimization, where the conversion happens at the access point level. And the reason why we need it is Aruba has always been a big proponent of centralized encryption. There are a lot of our customers, especially in the financial vertical and in the federal, the government vertical, who value centralized encryption. And there are a lot of people who require distributed encryption, where the dot level or decryption happens at the access point level itself. Right? So for customers who require centralized encryption, there is DMO, where the conversion happens at the controller. And for others, there's conversion that happens at the access point level. And at that, put together with all the ARM-based features, specifically band steering, making sure all your clients, all your dual band cable clients are pushed to the 5 GHz radio. And it's not just single direction band steering, where 2.4 is moved to 4, 5. It's also 5 to 2.5, especially with iPhone now supporting the 5 GHz radios. You want to make sure you're using both the radios so that you're not throughput limited or channel limited. And there is spectrum load balancing that Paul just talked about in a multi-AP environment. You want to make sure that it's not clients are not just balanced on the same access point level, but also across different access points based on the available number of channels and the channel utilization and whatnot. And lastly, airtime fairness. Right? So what we are seeing today is, a few years ago, usually when customers or prospects tested multicast, it used to be a 500 kilobits per second video or a 1 Mbps video, and now it's moving more towards HD video. Right? These days, when there are bake-offs and pilots, people want to test videos that are 4 Mbps in size or 10 Mbps in size or whatnot. Right? And more what we are finding is, as we look at these videos, the video that they're using to test makes a huge difference in terms of the scale that you're going to expect. Not every video is equal, right? Because not every video is a CBR kind of video. We recently ran into a bake-off where the bake-off was, we were supposed to be testing a 4 Mbps video, but the 4 Mbps video would spike up to 13 Mbps. So if you think about a single radio, and you probably are expecting around 40 clients that could stream a 4 Mbps video without any artifacts, without any pixelation. But whenever it hits that 13 Mbps spike, the AP is going to be doing so much work in converting all those multicast frames to unicast frames to all the clients that are associated. At that point, your channel utilization is probably only 50 or 60%. Your AP's utilization is going to be very high because of the amount of work that it has to do. So where is the bottleneck, and how do we deliver those frames as efficiently as possible? Is there some kind of traffic shaping algorithm that you have on the controller? Is there a traffic shaper on the wide network that is doing the shaping aspect of things and sending the shaped or polished package down to your controller? Or there are a lot of different things that we need to keep in mind when we do multicast testing. Recently, there's been a lot of discussions around support, multicast video support, and whatnot from some of our competitors and a lot of other people. So we wanted to show you a multicast video test bed at scale. So what we have here is approximately 40 devices, exactly 40 devices. We have one access point that is actually sitting right here. We have one SSID that is being broadcasted on the 5 GHz radio. Right? We have features, all our enterprise class features that most of our customers use today, like ARM, or web-to-web scanning and spectrum monitoring and whatnot, all that turned on. And what we want to show you is that we can scale up to 40 laptops that are streaming a 5 Mbps video without any pixelation, without any artifacts and whatnot. And the reason we're able to do this is there's a lot of optimization and enhancements that have gone into our recent code release in terms of enhanced aggregation, better scheduling, more additional buffers to accommodate those high spikes or high bursts that shows up in videos and whatnot. So
can you do some frame captures for us, because we left our PCs in the other room, so that would be interesting for us to look at as well.
Sure.
You want to grab your...
Yeah, sure.
So we'll send the configuration that we have on the controller right now to Jeannie, and maybe Jeannie can forward it, or I can just send it to you guys if required. So let's wait for him, or we can just get started. And yeah. So we have a client that is connected, that's wired in to the network, and there's bandwidth meter running on the client. We have this up just for you to know what the bit rate of the video is that we're using, and how much time, how constantly is it within 4 to 5 megs. We're using VLC as the video source. This is a Cars video for those of you who haven't seen Cars. We have probably seen the movie, or we have never watched the movie as such, but we have seen this Cars video probably 1,000,000 times now. I honestly don't know what is going on in the movie.
And it's interesting, Pixar and Aruba testing.
That's true.
Yeah, good point.
And there are a lot of interesting things that we have noticed, right? When there's a lot of movement in the screen, the spike just goes up. When there is a lot of lightings in the screen, the spike again goes up. When the video is really dark, it stays at 4 Mbps or whatever the encoded bit rate is. So this video, we have made sure that it is pretty tight within 4.5 to 5 Mbps. But in general, when you download, let's say, a video from Vimeo.com or YouTube.com, that is typically what you would expect.
Do you notice a lot of variance between going to certain websites like YouTube compared to Netflix or other sort of sites for their performance in downloading stuff?
Yeah, so YouTube, so most of the websites that we have noticed kind of rated up their video bitrate based on your network quality. So that is something that we have actually tried to do in terms of performance testing.
Okay, so they're actually optimizing it.
They optimize it based on network quality, yeah. And from what we've heard, the best quality that Netflix offers today is about 4.5 to 5 megs.
Okay.
So Bala, I see some spiking Probably, what's the maximum that you see there with the data rate, about 5, 5.5?
We've actually seen this video spike up to 9 megs in one particular interval.
So 40 laptops, one single radio, we're looking at over 200 megabit per second for that radio.
What channel are we on?
We should be on 52 or 60?
Channel we're on right now. We're on 52 plus.
52 plus.
Cool, thank you.
Could we see the controller view of the clients and them on the radio and everything?
Yep.
Sure.
Yes, I'm going to do it.
Hold the RGB.
Have you guys done this test where instead of having it all sitting here looking pretty where we can watch every screen, have you done it in more of a real world environment with the laptops dispersed through these cubes and having different distances from the AP for each of the clients? And
Absolutely. So, I mean, a couple of things that we've tried here is having 1 or 2 laptops per cube, which is usually what we would expect. Each user carries at least 2 or 3 devices these days. And the AP is mounted typically like what you would expect in real world and run the test. And the performance is pretty, as long as we follow the best practices of having the APs and transmit power channel settings and whatnot, it's usually what you'd expect.
so, define what I would expect.
As long as you have, you design for capacity. You have APs that are close to each other in terms of capacity, and you define your application requirements.
So the data rates are always high, that's where you're...
As long as the rates are high.
So what happens if you insert other applications with higher quality of service settings, like voice or whatever, especially have more than just a one VoIP call, so I don't know, it's loaded.
Data, right?
Yeah.
Yep.
Or not necessarily the stadium, you'll have difficulties installing this in stadiums, it's hard to control. But still, you could have applications that are running at higher quality of service. So
I mean,
have you
there
tested
are
that?
a couple of different things that we can do. So, few things. So, if the application is tagged at the source, before it's ingressing the wireless LAN infrastructure, if it is tagged with the right quality of service settings, we can, take those settings and translate it to the appropriate WMM queues and send it out of the high priority queue faster. For example, there's a voice application, you send it out of the standard WMM voice queue.
Yeah.
That gets higher priority than the video traffic.
Exactly.
So there are some applications where you cannot tag the traffic per se at the source, but as long as we know.
Multicast is best effort, right?
Right. And for example, for multicast, what we can do is we can define a ACL on the controller, which says any traffic that is headed to this particular destination or any traffic with the multicast address of 224, whatever the address is.
So
Send
as
it out of
it's
the
mainly downstream anyways,
we have complete control over all the packets. So we mark it, we send it out of the high queue.
So as I'm watching the videos on the laptops, I'm seeing everything from pauses and jitter and artifact, basically across the board, on a semi-regular basis. How many clients do you have to remove in order to get 100% clean video 100% of the time?
So that was my first assumption when I looked at cars. The video itself is a little. So do you see? So 40
I'm
clients.
seeing
should
like
be
pixelation every once in a while on the track. I'm seeing pauses and stops and stutters.
I can't tell from here.
Oh.
If you want to walk down and watch it closer, because a lot of the video itself is a little tricky. There's a lot of flashes and everything.
Yeah.
But I think to that point, would you recommend that you run single radio with 40 clients running 5
So this is a
video?
stress. This is a stress test. This is the maximum
max
maximum performance test.
It's still pretty impressive, though, I'll tell you.
You can always knock off a few clients. Right now we have 40 clients on a single radio, about 200 megs of UDP traffic over the air. You can knock off maybe 1 or 2 or 3 clients. We can always test that out, come up with the best case number, which I wouldn't expect should be less than 37, 36
And really, just to quickly add, you're going to want to have your video well characterized. Let's say your school environment. You want to run videos for the classroom. Maybe you have 30 students in the classroom. So what are the kinds of videos you're going to watch? So you want to characterize those first. Figure out, do they burst up to 12 megabit per second? Do they only go up to 2 megabit per second? That's going to make a big impact on how many clients can you support on a typical average day. And you want to test it out, maybe spread them out, to your point, throughout the classroom and not just have them all in a bang. And that'll give you a better feel for the capacity planning function that you have to do as you're deploying your network, and how many clients per AP you could expect.
You can help me better understand. This is more of like a buffer, right? This isn't, have we tested real live video going across, like somebody holding a presentation? Because this is more of a buffer event, right? Because we're streaming a video that's buffering.
There's some buffering needed in the
There's a
client.
little bit of buffering, but this is not like YouTube video, which is progressive download, where the client downloads the whole file and then it starts playing it. It's more of a, if you maybe unplug the AP now, the video might play for a few seconds and it'll just stop.
Yeah, I'm going to pause the video.
Yeah, if you can just pause the video. Or just stop it and restart it again. Let's see how long the client's able to play. They probably buffer for a few seconds, but it's not a lot.
Okay.
It's boosted up there.
So any other questions on what we're seeing and
Yeah, so what would be your best case, or what would be the best practice when using this in a mixed environment? So how many multicast devices would you propose to have in an environment?
typically it depends on one, the client type. If it's 11N, if it's a completely greenfield 11N environment, then something like 40 clients is what you can expect for a 5 Mbps video on a single radio per se.
Yeah, but
It's
when
gonna
you
depend
mix
on
that with data and everything else.
It depends on a lot of things, right? So what's the mix between people watching video versus people using the internet to pull down Outlook traffic, right? Is it going to be 80% Outlook, 20% video, or 80% video, 20% Outlook? What's the data rate of the streams? Are those going to be iPads or single stream phones that are going to be downloading data off your Wi-Fi, or is it going to be other 3-stream clients? How much contention are you going to have? So it gets to be a little difficult to get an exact number. It depends on the exact application, right? If I'm in a classroom environment where all the students are going to be watching a video at the same time, up to 35 should work. If you're doing 4 or 5 megabit data streams, no problem. If you're more in an office environment and everyone's going to be streaming a live updated webcast from the CEO and doing other work in the background, you probably want to bring that number down to say 20, right? Because a lot of it has to do with how busy the airtime gets and what's going on. When we brought up the controller dashboard, we were showing something like 70 or 80% channel utilization, right? You're not going to be able to get much beyond there without having problems. It's just running to the physics of the air. So it really depends on how much data you want to push and what your mix is. And unfortunately, it becomes very customer specific at that point. 20, no problem doing a lot of other stuff. 40, it's going to get dicey if you're going to be having another 40 laptops pulling down Outlook, some people on VoIP calls and doing some other things.
And that's a perfect point, because you wouldn't want to, you have to design to that, right?
Yeah.
If you know you're going to have 40, you're not going to put one AP in there. You might put 2 or 3.
This is really just trying to showcase the headroom that is there on the AP. And personally, I think it's pretty impressive to have 200 megabits of video coming through a single radio to kind of push that data out. And if you want to take a closer look, please feel free to walk out. I personally don't think there are a ton of artifacts, but it's just kind of the way cars is. It looks a little strange. Anyway.
And just to add to what Peter mentioned, there's a lot of enhancement that has gone into our most recent code release to improve your aggregation, improve your scheduling and whatnot. And we very strongly believe that 40 clients doing a 5 Mbps video on a single client is probably one of the leading in the industry today.
So these are all 3-stream laptops, are they?
Yes.
Oh, definitely.
Yeah.
6300.
It's a mixture of MacBook Pros that have a Broadcom 3-stream chipset and a Dell laptops which has an Intel 6300 chipset.
I mean, how many classrooms have 3-stream laptops? Like,
That's all.
So this is again the best case maximum performance scenario, right? That number is always going to be dependent on the client type.
Can we just see what happens if we plug one out and just walk down the corridor? So how it will, and when it will affect the others?
We can do that.
Sure.
Yeah.
And if you want to walk with it.
That's not what this is.
Yeah, we understand the exercise, but as we hear, it's
Should we, do we have time to do that, or should we move to the next demo? We can always come back to do
And I'd
it.
rather see.
We could come back during a break and do it.
Can we come back during the break, because we have a tight agenda, there are a lot of other demos planned and a lot of other sessions.
Sure. It's a good test.
It's a perfect test for measuring airtime fairness.
Cool.
Okay, let's move on to the next.
Okay, so the next test case, the second test case that we're going to spend some time talking about today is BYOD. Right? That is again becoming mainstream. People are all talking about BYOD. There's a lot of interest on getting the devices onto the network. Aruba clearly has a great solution with ClearPass for onboarding, provisioning, and all that. But the question is, what happens after the device is on the network? Right? Each user probably, you have a smartphone, you probably have an iPad and a laptop. And what you see, actually, you're sitting in the middle of our test bed. Where you are right now is our BYOD performance test bed. And the three devices that you see here kind of represents one user. So we have totally 60 devices connected to the access point that you see right there, AP135. And it's a mixture of 20 laptops that are all 3 spatial stream laptops that are capable, that you can do up to 450 megs of data rates. And iPads, obviously single spatial stream devices, and iPhones that are single spatial stream devices. The way we have done it today is we have distributed all the 5 gigahertz capable devices. We have pushed them to the 5 gig band using band steering, or prefer 5 gigahertz, which is a soft knob which says, if you are capable, please feel free to go to the 5 gig radio. All the 2.4 gig radio that can, the iPods that can only do 2.4 are obviously 2.4. And what we want to show you today is the impact of having a mixture of devices that has different capabilities. Right? Again, this is where airtime fairness comes into play, where you want to make sure that irrespective of what device you have, what operating system it has, or what chipset it has, it gets its own fair share of airtime over there. Right? The whole idea is the slower client should not be pulling down a faster client's performance, and a faster client should not be dominating the air with its performance because it's faster. So that is the whole concept. It used to play a major role 2 years before when there was a legacy to 11N transition. We still see a lot of customer deployments and bake-offs that we run into where we have a mixture of devices. It is becoming even more important today with devices with different characteristics. Like Windows Surface comes out, it has a different chipset. The next model of iPad might have different chipsets. So how does all these different chipsets interact with each other? And is your wireless LAN infrastructure intelligent enough to identify these different devices and guarantee that slice of airtime? Right? So the expectation is, when you do not have airtime fairness, slower device is going to pretty much take down or pull down your laptop's performance. And what we'll show you is with airtime fairness, your laptops are performing at about 60, 65 megs aggregate throughput for all the 20 devices that we have. Your iPads that are sharing the same radio with the laptops will probably get around 20, 25 megs. And your iPods that are on a separate radio will get what you expect, that's around 30, 35 megs.
Is the airtime fairness setting static? Or can you adjust it also to provide some sort of SLA services so you can differentiate one user's iPad to another user's iPad?
Today, the airtime fairness setting is static. You either say enable fair access, you give equal airtime to everyone, or what you can do is enable something called preferred access, where you can say the faster clients get more airtime. We also have bandwidth contracts on a per user basis, where you can define the upstream, downstream balance contracts. That is up to where we can do today. But that being said, a lot of new additions, a lot of things that we are thinking about for our next revision of ARM. Maybe that's for the next field day.
No, that's all kind of confidential still, unfortunately. If we get NDAs with you, we can share it, but I know you all want to blog everything.
I have an NDA.
Progressive, yeah.
Okay, so what we want to show is, so we're going to show you the Chariot interface, the Xia Chariot interface. And we'll walk you through what the test script is, what is the test flow, how much traffic are we generating, the protocol, and whatnot. We'll run the test in front of you, and we'll show you what the results look like. Not sure if you guys got a chance to look at our most recent test report that we published on BYOD. This is the same exact test case that we that's part of the report. So for anyone who has done RF testing, you know how flaky the devices are and the endpoints are. So if the test does not start for some reason, please bear with us. We'll have to kind of quickly run around and make sure the XCI endpoint is on and it's not stuck in some weird state.
Yeah. It's not easy device to work with.
I know. I mean, a few years before, when all the devices were laptops, we had an Ethernet port, and we could have an out-of-band management with wide network. Unfortunately, these devices don't even have an Ethernet port. Did it start the first time?
Yep, it actually did.
How many times does that happen?
How long is this run?
So just to give you a overview, so we are sending bidirectional traffic to each of the devices in test bed, right? Upstream and downstream. So this is TCP only traffic, and we can go over the script that we're using for TCP, and the test is being run for about a minute.
Should be run for a minute. He was running it for 10. So
Oh.
we're going to rerun it.
We should probably run it for a lesser duration of time.
You want to first show the script maybe?
Yeah, I'd like to see the script.
Let's run the test first, get the results, and then go over the scripts. All right, the little guy started running.
So it's got to be enabled by in person.
Okay.
That's fair.
I'm expecting to see the same test results, although there are only 45 water bodies right in my test bed.
So the people in the room do impact the performance, right?
They do.
Absolutely.
Absolutely.
Yeah. Ugly bags of mostly water.
And beer.
Think for yourself.
And hear from us.
Hey now.
We might be dehydrated after us.
While this is running, so we're clear on the previous test, the multicasting, were you converting multicast to unicast, or were you multicasting to all of the devices?
We were doing multicast to unicast conversion at the access point.
Okay.
Did you get a tip?
Mhm.
Cool. I guess we can ask him.
I can show it.
You want to share that with him?
No.
After you blog it?
Yeah, you're right. He'll share the link to his blog post.
No, I want to open this app.
Let's give it some time to pull all the clients back and get the data. It's pretty close to what we have seen, but I would have expected it to be a little better.
So what's the difference between the ups and downs?
So upstream is you're sending traffic from the client to the access point, and downstream is the other way around. So we created application groups for each application type for each device category.
The Ixia host itself, I would assume, is sitting on a wired client.
Correct. So the laptop that you see right there is our server.
Okay.
Okay, so the test is completed. So just to give you a walkthrough of the results. So obviously these are our MacBook Pros, right? And if you look at the aggregate performance for downstream, it's about 18.8 megs, and for upstream it's about 29.9. And combined both, it's close to about 45, 50 megs. if you look at the iPads, that's the top two, iPads upstream and iPads downstream, it's about 8 to 9 megs. Again, iPads are sharing the same radio as the laptops. Laptops are the faster clients who are performing better, close to about 50 megs. Ideally, we would have seen 65 to 70 megs based on all our staging in the last few days. iPads, ideally, I would have liked to see about 20 megs, but we're seeing a little bit of a performance difference. I would attribute that to all of us sitting in the test bed here. iPods are getting about 12 to 13 megs. So which kind of shows that your faster clients are able to perform better in an environment where you have fair access enabled.
Can you switch the access enabled off and then run it again so we can see the difference?
We can certainly do that, but again, so are we still tight on time?
We're pretty tight on time. We could take more tests during the break.
So let's do that during the break. We should probably move on.
Script real quick. Just talk a little bit about it.
Yeah, see the, yeah, what's the result?
So it's a TCP, we're sending TCP traffic and we're using the standard throughput.scr script. I'm sure you're familiar with the script from your day-to-day. And we are sending a file that's about 1 meg in size. We're not trying to push too much. It's about 1 meg of upstream and downstream traffic to each device. And the key here is, right, we are trying to send the same amount of data to each device. So that kind of puts the onus here on the device and what it can do.
What's the packet size?
Packet size is set to auto, but I would assume it's in the 1400, early 1400 bytes, excluding the GRE. And okay, so that was the first part of my demo. Unfortunately, you'll have to see me again. But until then, I'll pass it on to Chuck, who will be talking.
Sorry, Bala, were you going to show the cloud real quick? Do we have time for that?
Yes. Let's show the cloud. I totally forgot about the most interesting demo today. Okay, so what we did was we just used a traffic simulation tool, right, to measure the impact of the mix of devices and the performance on each device category. So what we want to show now is kind of break it down into a smaller subset of devices where we will be sending traffic to just the 10 devices that are sitting here, actually not 10, but 30 devices that are sitting in this quadrant. That's going to be background traffic on Ixia. Think of it as random chatter that is going on in the air in your enterprise, right? And we have 4 laptops in that quadrant that are trying to download a file from a cloud storage application. One is Box, one is Dropbox, the third one is Amazon Cloud, the fourth one is Google Docs. Right? So the key again that talking about what Paul already described is with BYOD, right? All these devices are walking into your enterprise. It's not just about the devices, it's also about the applications that are also walking in with those devices. So there should be some kind of a way that your infrastructure provides to, one, identify those devices, two, to set policies which says, hey, for example, Box is a corporate application that we care about, because that's where all our files are. And we want to make sure that any traffic to and from Box is prioritized over all other random traffic that people might want to use. I want to use Dropbox personally. I'm kind of I think that's better than Box, but the corporate policy here is box.com. So what we're going to show you is prioritizing box.com. We have uploaded the same file that's about 30 to 35 megs in size on all these 3 different cloud servers. And we are going to download the file on 4 laptops on these 4 different cloud applications, while there is some background traffic going on amongst these devices and the access point. A very typical use case you would probably see in an enterprise. Right? So I'm just going to ask some of my colleagues to help me out here.
You want to point out which laptop is which?
Yeah, so if you guys want to just walk down, look at what is going on, feel free. It's a very simple use case. That laptop is running Box, that guy is running Dropbox, this guy is running Amazon, and this guy is running Google Docs.
And what radio are those on?
These are all connected to the same access point that the other 60 devices are connected to.
Same access point, not same radio. Right.
Sorry?
I mean, some of these, like the iPods, it's going to be 2.4.
Yeah,
I
so
was asking, are these on 5?
These are mostly
these
5
are all
gig.
in 5 gig, yes.
Okay.
Which
So
channel?
the iPods are still connected to the 2.4.
Right.
So we don't want to remove them just for the test case. So to begin with, we'll start with the case where the traffic is prioritized. There is quality of service applied. We are identifying Box sessions and we are prioritizing it. We'll start with that case, and then we'll move on to maybe the case where we disable quality of service and look at how long does it take, or what is the value add of the feature.
Ready?
Yep.
So you timing the time it takes?
Let's say 25 seconds for the Box session right here, which is downloading. What's the timing that you guys will see? Can you start this?
Mine is Amazon is kind of still going on.
So let's just measure the time
Yeah.
and report the time after the download's completed.
Yeah.
I have the Box servers in the cloud are not overloaded with requests at this point. That will totally change the results. We are taking care of the Wi-Fi part of things, but after the WAN it is the WAN.
So we have background traffic running at this time to
Yes.
half the devices,
That's it.
and we're not prioritizing anything.
So
We are prioritizing
Box.
Box
We are
to begin with.
prioritizing Box.
Yep.
Because it's indicating the device itself is
No? What's
Yeah, it's 20 seconds to go.
I mean, if you want to take a look at those 4 applications, you'll see a clear difference with Box, the remaining download time on Box, and all the other applications. So there are a few other things that you can do because of the firewall and the control that it provides, which is you can either say deny Dropbox on my network. You can say deny Amazon on my network, or permit it, or throttle it based on what the corporate policy is.
So what is the quas based on? Do you have to put in the actual, if it's using specific ports, or do you actually have those applications
So
in there?
Just
Is
that
1 minute 20 seconds for Box, and I think the others are still 50% or thereabouts going on.
so Box completed download in about 1 minute and 20 seconds. So our expectation today was about 25 seconds, is what we saw at 7:45 before you guys walked in.
And this is with all the, you can actually show the chariot script running in the background.
So the way we do it today is, obviously the firewall, with firewall we had the first level of visibility, right? We have SIP ALGs, you can define policies and whatnot. So we have also added URL based visibility, where you can where the controller has predefined named aliases for the most common applications that are enterprise cloud applications that are being used today. It could be Box, Dropbox, or all the other apps that we mentioned or talked about. There are also additional visibility that we're adding in terms of UCC, unified communication and collaboration-based apps. For example, Webex, GoToMeeting, and obviously Microsoft Lync is a feature that we have developed ALG specifically for to look into the encrypted session, prioritize voice, video, just the media packets and whatnot. So the way we do it is we specify a ACL, which says any traffic to and from Box. Box is a cloud server that's hosting the file, needs to be prioritized over others.
And that's just for downloads then, right? Because upload, the client would have to be prioritising WMMs or whatever.
So the policy is implemented at the control level. So even for the upload traffic that is going up, the control will look at the destinations and tag the traffic appropriately.
But from a WMM perspective, how is the client getting priority then if it's uploading?
For the upload traffic, yes. So that is
Still
something
gonna
that
be
is not
Same
that's
problem
not
with
something
any
that we do.
application that we don't have control
Yeah.
over the
Yeah.
application, so the upstream we're not going to have effective control over. Obviously, we have some limited control with airtime fairness and getting a cleaner airspace.
Mhm.
Clearly, the downstream is where the most impact is. So the accessless rule is right here.
So this is what we have, which is any source that's going out to box, permit, mark it with a toss value of 40. There are the other applications that we have been testing with. For example, iCloud, as we know, you download something on your iPad, it automatically gets synced. The user does not even know that there is this traffic going back and forth with the other two devices in the same iTunes account. Right? So that's going to eat up a lot of your airtime, and that's exactly that needs to be controlled or throttled. And obviously Google Docs that we just showed.
So the destination, you just put in the URL?
Right now we just put in the URL, and controller does the job of translating the URL into a list of IP addresses that the server wants. Yeah.
When is it doing that translation? When I create the
When the
alias,
when the
or
when
is
the
it
first
continuing?
DNS query goes out.
So can you bypass that just by using an internal DNS server or the IP address of the server that you're trying to go to instead of the fully qualified hosting?
It does not depend on which DNS server you use. As long as the first query goes out for what is the IP address of, in this case it's boxcloud.net that is hosting the file. What is the IP address of that URL? It does not depend on what DNS server you use.
So afterward, the filtering is based on IP and
Mhm.
not the domain name, is what you're saying?
Correct.
Yeah.
And so what if your first query isn't done using a domain name? What if you're using the IP address of the host that you're trying to get to, as opposed to a fully qualified domain?
So the controller has a table, mapping table of all the firewall DNS names with the DNS name and all the list of IP addresses. So if you can just bring up show firewall DNS.
DNS hijacks are easy, right?
Yeah.
So the controller's actually doing its own lookup and
Yeah.
not
It is doing it.
listening to the response?
So let's do an initial query when I create the alias. We would have to have an IP to match with.
Hey Paul, how are we doing on time?
I think we should wrap up soon to segue to Chuck once we're done with the demo.
I just want to show the DNS table and then
Yep.
Chuck. Yep, did I know? This is totally unreadable.
Run that one more time.
If you can do it one more time.
Oh, yeah, understood.
Okay, so right now these are the aliases that we have already populated on the controller, and for each URL it translates it into multiple IP addresses that belong to the
Again,
URL.
that list gets populated when a client initiates a name lookup, not when you enter the rule?
My understanding is when the client initiates a lookup is when the list gets populated.
And how long do you keep those names? How long do you keep that table?
I'm not exactly sure about the timeout interval, so that's something I can maybe get back to you on. But this has been here for almost more than a week now. So
I still don't think, at least I didn't hear an answer to what Sam was asking, is that if you hit the IP address, are you doing reverse DNS lookup to check to see what that IP address? So if I just go to, let's say 74.112.184.96, which is currently listed as box.com, was not in your table. And let's say I go to 74.112.184.96. Are you then doing a reverse DNS lookup to see, does it resolve to something, and then putting that into the list if it comes back?
Yeah, if you have a client that's trying to circumvent the whole DNS because they happen to have heard somebody say something, they're like, oh, well, I'll just go to the IP address or whatever.
We need to double check on
I
that.
believe
I'm not
believe
entirely sure. I believe once
we
it makes
do,
it into
but
this list, it's in the list and we'll check against it via IP address. So if anyone on that
Else.
controller has ever looked up box,
Okay.
when you then try and go to that box IP address, you're gonna be caught.
Okay.
But we need to double check and verify with the developers just to make sure we're telling you the right.
Would that affect anything? I mean, some
The
of these,
younger, the more so.
some of these services are hosted at like Akamai,
Yeah.
Mhm.
and they're gonna share an address.
Yeah.
Mhm.
So you may have a legitimate service with the same IP address as
Isn't
a
it?
block
Yeah.
service.
Right. That is again something that we'll have to check. So today, I doubt if we follow the HTTP transaction per se, because you go to Box, it doesn't mean the file is hosted on Box. It's
Right.
referred to something else. So that is something that we'll have to check. But my understanding is today we just do URL-based resolution and prioritize the traffic that goes to that particular URL.
So we're
Again,
we're
this
probably
isn't-
going to be able to
Yeah.
get the developer in here to talk about that specifically a little later on. So why don't we hold the questions for now? They're all very good questions. So